Well, in the previous video, we were talking about ski hills. And a skier on the ski hill can only see the slope of the hill close to where he is. So let's look at that picture again.
Can you get rid of the pink hill there so we could see the graph better?
Sure, that's a good idea, because the ski hill, of course, is a three-dimensional thing. We just want to see a nice, simple, two-dimensional plot of a parabola. So here we go. Here's the ski hill, and we see a point on the hill. And what we want to do is figure out what is the slope there. So what we can do is put in a line that best represents the slope, like this.
Well, that looks pretty good. How did you make that line?
Well, what I did, of course I did it mathematically, but what I did was I took a look close to that point and said, what's the best line that fits into this little slope? So that particular line worked well for that point, but what I want you to notice is the slope changes if I go to different points on the curve, like
so
this.
The slope is a function of where you are on
Exactly.
the parabola.
Exactly. So this slope is also a function. The parabola was a function. The slope is also a function. Now, which curve should we use? Well, if we zoom in, which is easy to do on my little animation here, you take a close look, and you see is when you're really, really zoomed in, the straight line here, which is the blue line, is very, very close to the purple line.
You can't really tell the difference clearly. That's fascinating, because we tend to think of things as local, but it's over a region that you can't tell the difference.
Exactly. So here we're looking locally, and we're looking for the best line. Now, I mentioned we picked the best line. We should look at a few other lines,
Yeah,
because
good
there are
idea.
other lines. So I can tilt the line.
Well, that doesn't look right at all, of course.
So I could go the other way. Does that look right?
No, none of those look right, because only the one that sits right on top of the line, you can't tell the difference.
That's right.
There's a region for which that approximate line matches the parabola really well.
And you mentioned a really good word there, the region. So the point is we're just looking at an approximation in a region right around this little point. If the function is doing something weird further away from the point, we don't care about that from the slope. So I can give you a little picture of that. Here the function is wiggling like crazy. And kind of say, well, that's going to mess up my slope. But Matt, what's happening right here at this point?
Oh, we can see that they match again really, really well.
Exactly.
Can you go telescope in and let's have a look?
Let's zoom in a little bit more.
Oh, same. And we can see the jigglies around past that region.
Exactly. If I zoom out, you can see there's jigglies all over the place. But from the point of view of finding the slope at a particular point, we don't care about what's happening way down here or way up there. It's only what happened right in a region around this little point.
Now, you've drawn that very strange function. In nature, can you think of an example? Because this is just a cooked up math example.
Well, it sort of looks like a cooked up math example, you're right. But I think we've all seen this picture of a bridge swaying in the wind. And at some point, the wind gets a right resonance with the bridge, and the bridge starts to violently swing back and forth. That's a very natural phenomenon called resonance. And it can go crazy, crazy until something like a bridge actually breaks. And that's a little bit about what this curve represents. Here's a little bit of wiggles, and then the resonance builds up, and it starts to oscillate like crazy.
Well, that's a good example. So there are the odd cases, but normally when we're first seeing this idea of representing the best slope, we're always dealing with fairly smooth curves.
And that's right, and that's what we'll see in later videos, that when we work with a nice smooth little curve, so maybe I can give us back our little parabola, and we look out at our parabola, things are pretty easy, and you can actually write down explicit formulas for calculating the slope.
What will we do in the case where you can't really write the explicit formula down? Because in most textbooks, they always have something simple like a parabola, a cubic, a sine wave. What if we can't really explicitly write it down? What would we do in that case?
For me, I sort of have two approaches. One thing is I would graph the function and kind of eyeball what the slope is, because that's a good intuition of what the slope should be. Another thing is you could take 2 points on the curve that are close together, compute the straight line going through there, and that gives you an approximation to the slope.
Sounds like a good plan. What else have you got to show us today?
I did want to show you what happens if something bad goes. Like here we've got a slope. It looks really pretty, but what happens if you have a little kink in the slope? Now that could happen on ski hill. You might have a funny bump or something like that. And you can ask the question, which is the right way to approximate the curve with a straight line? Here it looks like this curve approximates it well above, but it doesn't do a very good job below. So I could go this way, maybe here, and that's a good approximation to the bottom side. But there's no one line that sort of approximates both things well.
You have to divide it into regions onto the left side of the kink and the right side of the kink, where that point exists, right?
Exactly.
So you can't have a single line there. It doesn't make sense. Because the curve doesn't make sense. It's not smooth anymore.
I'm getting distracted, but you're exactly right. The curve is not smooth, so we might not have a well-defined slope there. And that's just the way it is.
And that's just the way it is. Where do we go next time?
Next time, let's take a look at how we represent these lines. We'll get back to our familiar line formulas and see how it fits into this idea of slope.
Looking forward to that.
Great. See you next time.